All right, hey guys, it is Miss Lastly and Miss Markert, and we are here for day number 7. We are going to be using our inverses that we learned how to make yesterday to solve equations. So we're not solving a system of equations yet. We will get to that next week, but we're just solving equations that have matrices in them. So this is something that you guys have definitely done before, just without matrices. It's kind of like your general 2-3 step algebra solve for x equation. So it's going to look really similar to that, but we're going to use matrices instead of just standard constants. I will turn it over to Miss Markert and she will give you guys the notes for today.
So just like Miss Lastly said, we're solving equations today. So let's just jump right in. So they do look very similar to just solving your standard x plus 3 equals 5 equations. We have these properties here. I put in this nice, lovely graphic because I didn't want to write all these out because that sounds annoying. So we have these properties that we need to talk about really quick. Most of them should look somewhat familiar. I know that we've probably talked about at least some of these, and that some of these should look super familiar. There's a couple things I want to point out, and then we're going to do an example and then talk about the homework for a second, and then that will be it for today. So here, one of the big things that I want to talk about is the commutative property here. As you can see, when you have matrices A and B, the commutative property holds. So if you have A plus B, it will equal B plus A. It doesn't matter in which way you add them. However, for multiplication, it does not hold. So if you multiply AB, it does not hold for B times A. And we looked at that a little bit last week when we did multiplication of matrices. It kind of has to do with order, but kind of not. So just, it doesn't hold. If you do A times B, it will not be the same as B times A. And that will come in a second here. But yeah. And then we have the associative property, which holds for both, which basically just means you can move the parentheses around. I don't think you really need to use that today, but there is that for you. The other property that is important is the identity property here. Remember that this I is just our matrix or identity matrix. So if you multiply A times the identity or the identity times matrix A, you're going to get A back. So essentially your identity matrix is equal to 1, kind of think of it as 1. And that comes in handy when you need to solve for things, obviously. The other property here that's important is this inverse property. This is how we're going to cancel out matrices and move them to other sides and things. So if you look here, if we have addition, A plus negative A is equal to 0. So same if you were just solving regular equations. If you have 3 and you're trying to move it to the other side, you would subtract 3 because you had a positive 3 there. So same idea. For multiplication, to get to the inverse, you have to use your inverse matrix, inverse property, inverse matrix. So if you have a matrix A and you are trying to get it to the other side, if you had a regular equation here, if you had like 3x equals 12, normally we would divide off 3 here and we would get x equals 4. In matrices, we don't really have division. We have the multiplying times the inverse, and so you're going to use your inverse matrix to get down to your identity, which is essentially 1, and that will cancel out your invert or your matrix. Okay, so with that being said, when you're doing your inverse property, which you will have to do in your homework tonight, it's important to remember the order in which you multiply. So if you're given an equation where you have AX equals B, if your A is on this side here, then A inverse has to be on that same side. So then it would go here for B. So it has to go on the same side. So if you had, for instance, X times A, where X is your variable, and this is equal to B, then you would have to put A inverse on the right side. So we would have X A equal to B, and then you would have A inverse on this side, like that. So let's see, here we would have AX equals B, and A inverse would be on the left side. On your homework tonight, I believe that all of your matrices will be on the left side of X. So just put all of your inverse matrices on the left side of whatever you're doing on the other side. Remember that the commutative property doesn't hold, so it does not work to just put it wherever you want. I know that at least when I solve other equations, I just kind of multiply wherever it will fit on my line that I'm working on. That doesn't work here. You have to keep it on the same side that it started on of whatever variable you have. So just keep that in mind. If you have to rewrite the line, I would do that to keep everything straight. It's super important that it stays on that correct side. So just keep that in mind. Yep. The last property we have here is just the distributive property. You guys have all seen that and know how it works. It holds, and there it is if you need it. All right, with that being said, let's solve one. So I have one example here, and then I'm gonna say a quick thing about your homework, and then I think we're done unless Miss Lastly has anything to add. Cool. All right, so let's solve this one. So the first thing that we're gonna do, like we would do in any equation, is we're gonna get rid of this spot right here, because remember, we're trying to isolate the variable that hasn't changed. So we're just gonna do the opposite. So we're gonna add -3 like this, and then we're gonna do the same thing to the other side. And we're gonna end up with -6, -3, 8, 3, x 33, and -43. Just like that. Cool. And so then that one canceled. And we're left with that one. Okay, so the next thing that we need to do is we need to find the inverse of this matrix, because remember, in a typical equation, we would divide that by both sides, or have both sides be divided by whatever that is, and then we would get our answer. But remember, division doesn't really work here, so we're gonna find the inverse matrix. So the first thing we need to find is the determinant. So remember that our determinant is a D minus BC, and I figured out which letters are which today, so hopefully that goes smoothly today. So our determinant for this one is 6. I did it this morning. I didn't just know that off the top of my head, but whatever. So then remember that for our inverse matrix, we have 1/6, and then on this line, we are gonna swap the two numbers. So we have 3 and -6, and then on this other diagonal, we're gonna just change their signs. So we end up with -8 and 3. And then we're gonna multiply out by our scalar, and we're left with 1/2, 1/2, -4/3, and -1. Then remember that the inverse has to be on the same side as your original matrix. So in this case, it's on the left-hand side, so we need to keep it on the left-hand side of whatever matrix we're multiplying it to. So I'm gonna keep our inverse matrix in blue so you guys can see that. So we have 1/2, 1/2, -4/3, -1. And then we have our other matrix, so -6, -3, 8, 3. X equals, and we have our inverse matrix, 1/2, 1/2, -4/3, 1 and 33 negative 43, and that's multiplied together. So remember, this has to be on the same side. So if you see here, this matrix is on the left-hand side, and so is this one. So keep that straight. Okay.
Yeah.
So then,
I was just going to say, with ones like these, it's obvious, right? Because there's only, if you try and put the blue matrix on the right-hand side of the 33 and negative 43, you're not going to be able to multiply. Remember, the order doesn't work out. You have a 2 by 2 times a 2 by 1, and you won't be able to multiply your rows. So you can see that it's obvious. But you are going to have some where it's a 2 by 2 times, say, another 2 by 2. And then the order isn't going to be a dead giveaway for which side it has to be on. So just remember the pattern, right? If you multiply on the left-hand side on one side of your equation, then you have to multiply on the left-hand side of the other side of your equation, right? And you can't break up, like some people say, like, but Miss Lastly, can I just put the -6, -3, 8, 3 matrix and then do a space and put the inverse there and then put X on the other side? No, you can't break up those two. They're kind of together. So you have to just multiply with the side that's kind of available. So don't try and do anything tricky. Don't make it look weird. Just go with what the problem gives you and you'll have the right answer. But if you mix up how you're supposed to multiply, you won't end up with the right answer. So just be careful, guys.
yes. And on your homework tonight, it isn't necessarily obvious which side it has to be on because the orders will match. So be super careful. Okay, so then because we are multiplying our matrix A here with its inverse, these will cancel into the identity matrix, which is essentially 1, and so we're left with X on that side. And then when we multiply out the other matrix, we are left with -5, -1. Remember, row by column, and then add them all together with your matrix multiplication, and that is it for our answer. So our answer to this equation is matrix -5, -1. The one thing I want to mention on your homework is that I think problem 6 is the only one like this, but it does have a couple 3 by 3 matrices. You should not have to find the inverse of that matrix. If you are finding the inverse of the 3 by 3 matrix, you're doing something wrong. The most you should be doing is adding something to it or multiplying another matrix by it. You should not be adding or finding the inverse of 3 by 3 matrices. So when you see that, don't freak out. You're just using it to multiply and add things. That's all we have for you guys today.
Cool. So this is basically just applying all of the different operations we learned last week. So we're adding, subtracting, multiplying matrices, and then doing what we did yesterday, which is finding that inverse of a 2 by 2 and then multiplying to kind of isolate, like Miss Markert said, our variable. So this should be pretty easy. A little strange to be doing this with matrices instead of just standard numbers, but I think you guys can handle it. Just remember the order when you're multiplying something over from one side of the equation to the other. Multiplication does have to be in a specific order because, again, like Miss Margaret said, multiplication is not going to work with the commutative property. That property does not hold with matrices, so you have to be very careful because order does matter when you are multiplying matrices. It's one of the very few subsets of math concepts that does not hold under the commutative property, which if you take any really fun math classes as you get later on in your career, like, I don't know, advanced calculus, you'll learn that property, or abstract algebra, homomorphisms and isomorphisms, and it's the worst class I've ever took in my life. But
yep.
You'll learn all about what subsets hold under the commutative property. Anyways, that was more information than you see. Miss Markert's having flashbacks. It's like PTSD.
Number theory was bad too. Ooh.
See, I got to skip number theory. I didn't take that class. It was taught by this professor at my school that didn't he had a very heavy accent, and I heard from a lot of people that it was really difficult to take his class. So I was like, I'm just going to dodge that bullet and take advanced differential equations, which was way more fun. It was super.
I had to. It was required for my degree.
That sounds terrible. That sounds terrible. But anyways, I'm sure you guys don't want to hear me and Miss Margaret talk about lame math classes anymore. But just remember, order matters when you're multiplying matrices. So please be careful on your homework tonight. But that is it. Tomorrow we are going to go into calculator operations, and hopefully we can figure out a way to show you guys how to do it. Me and Miss Margaret are probably going to brainstorm a little bit after this video session, and then we're going to show you guys how to do the same kind of thing with a 3x3 matrix and how to find that inverse. We are definitely using our calculator for that because it is too daunting to try and teach you how to do it by hand when we're just doing a video. I usually make them do it by hand. You guys lucked out. You're welcome that there's a quarantine. Some things are just better when we're quarantined. So you just aren't going to have to learn how to do that by hand. But we will show you how to do it on a calculator. Yes, and then that'll kind of be the end of stuff for this week because Thursday we just have our live stream and our review day. But yeah, so we're almost done with week 2 of matrices, and there's only one more week left of new content. So hopefully this hasn't been too awful for you guys. And like we've been saying all week this week and last week, if you are taking AP test, good luck, do well, and we will see you guys tomorrow. Bye.